Our solar system is a vast place. For centuries, we thought we knew its planetary citizens. Then, astronomers noticed something. Uranus and Neptune wobbled a bit in their orbits. Something else, something unseen, seemed to be tugging at them. This mysterious object was dubbed Planet X. The hunt was on. Many searched for this elusive world. It was a cosmic detective story. The clues were faint, the distances were immense. It was a challenge for the ages. An astronomer named Clyde Tombaugh took up this challenge. He worked at the Lowell Observatory in Arizona. Percival Lowell himself had started the search for Planet X. Tombaugh was incredibly patient. He spent countless nights at the telescope. He meticulously compared photographic plates of the night sky. These plates were taken days or weeks apart. He was looking for a tiny speck of light that moved, a speck that betrayed itself as a wanderer against the backdrop of fixed stars. This was painstaking work. Then, in February 1930, he found it. Eureka! A tiny, faint dot had shifted its position. This was not a star, this was something new, something orbiting our sun. The news electrified the world. A ninth planet had been discovered. Imagine the excitement. Our solar system had just gotten bigger. It was a triumph of human curiosity and persistence. The universe still held surprises for us. We just had to look carefully. The new world needed a name. Suggestions poured in from everywhere. A young girl in England, Venetia Burney, suggested Pluto. Pluto was the Roman god of the underworld. It seemed fitting for such a distant, dark, and cold world. The name stuck. Pluto officially joined the family of planets. It was the smallest. It was the most distant. It was, for a long time, the most mysterious planet in our solar system. Its journey had just begun in our understanding. For many decades, Pluto held its title. It was the ninth planet from the Sun. School children learned its name. They memorized its place in the solar system lineup. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. It seemed settled. But science is always learning. Science revises its understanding. Pluto's small size and unusual orbit always made it a bit of an oddball. It was much smaller than other planets. Its path around the Sun was very tilted. As our telescopes became more powerful, we started seeing more. We peered deeper into the cold, dark regions beyond Neptune. This region is called the Kuiper Belt. Astronomers began discovering other icy bodies out there. Some were quite large. In 2005, astronomers found an object named Eris. Eris appeared to be even more massive than Pluto. This discovery sparked a big debate. If Pluto was a planet, then what about Eris? What about other large Kuiper Belt objects? How many planets would we have? The International Astronomical Union, or IAU, is the organization responsible for naming celestial objects. They decided it was time to formally define what a planet is. This was a big task. Scientists from all over the world discussed and debated. What makes a planet a planet? Is it size? Is it orbit? Is it how it formed? These were tough questions. The universe doesn't always fit into neat little boxes. Nature can be wonderfully complex. In 2006, the IAU voted on a new definition. A planet must orbit the Sun. It must be nearly round due to its own gravity, and crucially, it must have cleared its neighborhood. This means it must be the dominant gravitational object in its orbital path. Pluto meets the first two criteria, but it has not cleared its neighborhood. It shares its orbital space with many other Kuiper Belt objects. So, Pluto was reclassified. It became the first of a new category, a dwarf planet. Many people were sad. Pluto was demoted, but this is science. For most of its known history, Pluto was just a faint point of light. Even our best telescopes on Earth showed little detail. It was a smudge, a mystery wrapped in an enigma, trillions of miles away. We knew it was small and icy. We knew it had a moon, Karen, discovered in 1978. But what did Pluto actually look like up close? What secrets did its surface hold? We had so many questions. We needed to send a robotic ambassador, a probe to travel across the solar system. NASA answered the call with the New Horizons mission. This spacecraft was launched in January 2006. It was the fastest spacecraft ever launched from Earth. Its destination, Pluto and the Kuiper Belt. It embarked on a journey of over 9 years. It traveled more than 3 billion miles. Think about that incredible voyage, hurtling through the cold, dark vacuum of space, heading towards an unknown, icy frontier. It was a mission of pure exploration, a testament to our desire to understand the cosmos. In July 2015, New Horizons finally reached Pluto. It didn't orbit, it flew past at high speed. During this brief encounter, its cameras and instruments worked furiously. They gathered as much data as possible. Then, the long process of sending that precious information back to Earth began. The first images were stunning, they were breathtaking. Pluto was not just a boring ball of ice, it was a dynamic, complex world. It had towering mountains, it had vast plains, it had craters, it even had a heart-shaped feature. The discoveries were revolutionary. Those mountains, they are made of water ice, hard as rock at Pluto's frigid temperatures. The plains, like Sputnik Planitia, the heart, are made of frozen nitrogen and methane. These ices slowly flow, like glaciers on Earth. Pluto has a thin atmosphere, mostly nitrogen. Surprisingly, Pluto showed signs of geological activity. This was unexpected for such a small, cold world. It challenged our ideas about how dwarf planets behave. Pluto, the underdog, was full of surprises. It was a truly remarkable place. So, Pluto is a dwarf planet. Does that make it less interesting? Absolutely not! In fact, its reclassification highlights something important. Pluto represents a whole new class of celestial bodies. There are likely hundreds, maybe thousands of dwarf planets in the Kuiper Belt, and beyond. Pluto is one of the largest and brightest of these. It's a king among its kind. Studying Pluto helps us understand this vast, icy realm at the edge of our solar system. These are the building blocks of planets. Pluto teaches us about the diversity of worlds in our universe. It's not like the rocky inner planets, it's not like the gas giants, it's something different. It's an icy world with a dynamic surface and a thin atmosphere. Its largest moon, Charon, is so big compared to Pluto that they are almost a binary system. They orbit a common point in space outside of Pluto itself. Pluto also has 4 smaller moons: Styx, Nix, Kerberos, and Hydra. It's a mini-system of its own. This complexity is fascinating. The New Horizons mission provided a snapshot. An incredible, detailed snapshot, but still just a glimpse. Scientists are still analyzing the data. They are still making new discoveries from that 2015 flyby. There are many unanswered questions. What powers Pluto's geological activity? Does it have a subsurface ocean? How did its system of moons form? Each answer will tell us more about how planetary systems form and evolve. Not just our own, but potentially systems around other stars. Pluto holds clues to these big questions. Pluto's story is a great example of science in action. We discover, we learn, we revise our understanding. Pluto may have lost its planet title, but it gained a new kind of importance. It's a gateway to understanding the Kuiper Belt. It's a world that continues to surprise and inspire us. The study of Pluto is far from over. This little underdog way out in the cold darkness still has so much to teach us. And that in itself is a cosmic wonder. Keep looking up.